everybody, this is the 2017 AP FRQ number 3. So in this problem, we're given the graph of f prime. It says that f is differentiable on the closed interval from -6 to 5 and satisfies f of -2 equals 7. And we've got the graph of f prime here. So in part A, it asks us to find the values of f of -6 and f of 5. Well, anytime we're given the graph of the first derivative and we're asked to find values of the original function, we need to use that initial condition that they gave us. So in this case, they gave us f of -2. So in order to find f of -6, we're going to start with f of -2 and then do the integral from -2 to -6 of f prime of t dt. So remember, it's the initial plus the integral, starting at the initial value to whatever value we're looking for. So we're going to start with 7. And let's see, -2 to 6 is backwards, so I'm going to make it minus the integral from -6 to -2 of f prime of t dt. And so now we need to look for the area. So from a -6 to -2 means we're going to be looking at this triangle in here. So let's see, that's going to be 7 minus 1/2. The base is 4 and the height is 2. So 7 minus 4. So we get that f of -6 is equal to 3. So that's our first answer there. And then we also have to find f of 5. So similarly, we start out the same, right? So we start with f of -2 plus the integral from -2 to 5 of f prime of t dt. So we're going to start with 7, and now we're going to be looking at the area from -2 to +5. So that's going to be this semicircle that's underneath the x-axis, so that's going to be negative, and this triangle that's above the x-axis, so it'll be positive. So let's see, 7, it's going to be minus pi, the radius is 2 squared over 2, plus 1/2, the base is 3, and the height is 2. So let's see, that becomes 7 minus 2 pi plus 3, so 10 minus 2 pi. And there's the answer for that. So for this one, this was worth 3 points overall. So it was 1 point for remembering to use f of -2. So did you remember the initial condition? And then 1 point for finding f of -6, and 1 point for finding f of 5. Part B here asks us to find where f is increasing. So we know that for a function to be increasing, we're going to be looking for where f prime is greater than or equal to 0. Well, since we're given the graph of f prime, we really just need to look for where is f prime above the x-axis. So we can see that that happens from -6 to -2, and then it happens from 2 all the way to 5. So f is increasing on -6 to -2 union with, what did I say, 2 to 5? Because it was a really bad C. I don't know what happened there. Sorry. F prime of x is greater than or equal to 0 on these intervals. This part of the question was worth 2 points, and it was really just for your answer and your justification. So 1 really for the intervals and then 1 for that justification. Part C here asks you to find the absolute minimum of f on the closed interval. Well, we know if we're finding an absolute, we definitely need to include the endpoints. So we're going to include -6 and 5 in our table. And then we need to include any critical values where there's potentially a minimum value. Well, a minimum value tells us that we're going to need the first derivative to change from negative to positive. So we can see right here that this is a critical point because it's when the first derivative is equal to 0. And same with both of these points actually. For this one at x equals -2, the first derivative is changing from positive to negative. So that one actually potentially gives us a maximum value. We can include it in our table if we want to, but it's not going to be necessary because it's not going to give us a minimum value. So I don't really care about it. And then this is going to be the one that we actually care about because that one does change from negative to positive. So for our table, we're going to have x, we're going to have f of x, and let's see, we're going to have our endpoints. So -6, that one critical value that could be the absolute minimum because we know it's at least a relative minimum. And then the other endpoint is 5. Well, -6 and 5 we already found in part A. So for -6 we got 3, and for 5 we got 10 minus 2 pi. So I'm not going to do those again. I'm just going to take them from part A. In order to get f of 2, we're going to have to start with that initial value again. So f of -2 equals 7. So we're going to start with f of -2, and we're going to do plus the integral from -2 to +2 of f prime of t dt. So that's going to be 7. And then we need the integral from -2 to 2, which if we look at our graph here, -2 to 2 is this semicircle that's underneath the x-axis. So it's going to be a negative value. So it's going to be minus, and that's that same 2 pi that we had before, actually. So now we need to figure out which one of these is the absolute minimum. So we've got 3, we have 7 minus 2 pi, and we have 10 minus 2 pi. We have to remember that pi is about 3.14, right? So if we were to have 2 pi, it'd be about 6.28. So if we were to do 7 minus 6.28, that would be something that's less than 1. And if we did 10 minus 6.28, that would be just underneath 4. So we know then that this is going to be our absolute minimum. So the absolute min is 7 minus 2 pi. And I always say where it happens. So at x equals 2. Part C here, let's see, was worth 2 points. So it was 1 point for including x equals 2 on your table because you knew that it was going to be at least the location of a relative minimum. And then it's 1 point overall for your answer with your work. And finally, on to part D here. So for each f double prime of -5 and f double prime of 3, find the value or explain why it doesn't exist. Well, we know if we're looking for f double prime, we're going to be looking at the slope of f prime. So if we want to find double prime of -5, we want to find the slope of f prime at -5. So if we think about where that is, -5 is right here. So we want the slope of f prime at that point right there. That really just means the slope of that line segment that's there. So let's see, that's down 2 and to the right 4. So -1/2 is the slope right there. And then if we're going to look at f double prime of 3, that means look at the slope of f prime at 3. Well, this one's definitely different here. So if we look right here at 3, we can actually see, even just by looking at it right now, that that's a corner. That's a problem right there. So the way that we're going to have to show this is we're going to have to look at the left and the right limits. So remember, finding a slope, we can look at the limit from the left and the right then, because that's what a derivative is. So if we look at the limit as x approaches 3, let's do from the left first, of f prime of x minus f prime of 3 all over x minus 3, then that means what's the slope as x approaches 3 from the left of this line? So from the left side means we're going from here, we want the slope of this line segment. So I'm going to get rid of some of this extra stuff that's here. We don't need all of this anymore. And it'll make it a little bit easier to kind of see what we're working with. Sorry. We want the slope of this red line segment right here. So let's see. We're going up 2 and over 1. So that's going to be a slope of 2. And we can do the same thing from the left then. If we look at the limit as x approaches 3 from the right of f prime of x minus f prime of 3 all over x minus 3, then that just means on the right side here, what are we looking at? What's the slope here? Coming from this side, well, that's going to be a negative slope, right? We're going down 2 and over 2, so that's actually going to be a slope of -1. So we can see then that f double prime of 3 does not exist because, and it's going to be the limit as x approaches 3 from the left, and we're going to have to write that whole thing. So actually I'm going to go down underneath so that I can write the whole thing in one big line to show you guys. So it's going to be the limit as x approaches 3 from the left of f prime of x minus f prime of 3 over x minus 3 does not equal the limit as x approaches 3 from the right of f prime of x minus f prime of 3 all over x minus 3. So we can look at the graph right away and see that because it's a corner, that's going to be a problem. But the way we want to show that is by looking at these left and right limits and writing it out this way. So hopefully you remember how to find a limit, right? And how to write that limit notation. If you have any questions on it, please feel free to ask. In terms of points for this one, this was worth 2 points overall. So it was 1 point. That was a really bad bracket there. That's better. It was 1 point for finding f double prime of -5. And then it was 1 point for saying f double prime of 3 does not exist with an explanation. All right, thanks for watching.